Alright, we are live. So let me check the audio again. Seemingly the voice isn't that high. Let me check. Okay, seems fine. Yeah, that was the echo of my laptop you just heard. Let's get to it. So I just realized that the Forge just updated their GitHub. So they put new code in. That means I need to like pull. So I have my PowerShell here open. And I'm going to first stash all the things that I've modified so far. Alright, my work is saved, and what I'm going to do is git pull origin master and dash dash base. So let's see what they've changed. I'm waiting. I doubt they've changed anything that we've touched so far, but who knows. I'm just hoping that nothing. Like, I'm mostly hoping that this doesn't take that long. Yeah, we got hit. Alright, that's nice. That didn't take much. And what I'm going to do is git slash pop. So off to a good start, seemingly. Yeah, I just lost connection, so we're back. So I was just I just popped my stashed stuff, and we had no conflict, so we have all our modifications here. And yeah, for those who are just starting to watch these series, this is a series on code reviews of the Forge source engine, the Forge engine source code. So yeah, we've made our way through the initialization function, and with all right, we are back for now, but who knows? Maybe later we're going to run into trouble again. So I was saying that this is the fourth session, and what we've been doing is to read one of the examples, material playground example. We've gone through the initialization function and made our way to some of the member functions, and we've got to know like some basic designs of the engine. I seem we have it. Yeah. Well, when did these happen? Let me see if this code compiles. So yeah, I've just got their new code. They put some new code on the GitHub, and I've applied my changes on top of that, and we're trying to build this. Let's see if this actually builds. Because Visual Studio is just showing, yeah, it does build, but Visual Studio is showing me some errors here. Yeah, it builds. So, one thing that we noticed last time, like yesterday, was that we had some static members and some structs in the iRenderer here. Static member functions in some of these structures. So let me see if I can search for static. Searching for static to find those. No, it wasn't here. Interesting. Where was it then? So that is anyway. The point is that that is not valid C code. Like you cannot have any kind of member functions inside your structs in C. So that is not valid C. That is C plus. That is valid C plus plus though. So yeah, our resource loader. I will try to find that code, and that code could like if we start noticing that some part of the code is actually C++ rather than being C, we could like start improving by adding references and stuff like that. So yeah, many people might have a question like why, what is the big deal with references and not the pointers, and not just simply using pointers. Like they might find this kind of review and nitpicking like annoying, but it actually does help. Like let me bring the renderer code. I believe some of these should be in there. Oh no, not that. Definitely not that. Definitely not that. That one. Let's find one of these functions that takes render. Pure render. Yeah. Initialize our render. So the code for this should be this is in the render files. Yeah. Thank you for finally opening the code from Visual Studio. So yeah, this is the point I'm trying to make. Like using pointers for this kind of stuff, this is just gonna force you to like do these kind of assertions here. Like you need to check every time that this uh, render pointer is valid, and yeah, this is going to get annoying. Like yeah, these assertions are going to help in debug mode, but what about the release mode? No, probably. So yeah, I don't want any kind of this. Like why? Also, if this pointer to render was a return type of this, like you would call this allocate renderer, and you would allocate a renderer depending on the input parameters and return a pointer to that renderer. That is fine C code. I can use that with a unique pointer. Like I could use this allocate renderer function to like initialize a unique pointer, and I would probably use the free renderer as the greeter of that unique pointer, and everything would just be RAI from there on. But with this method, I cannot initialize a unique footer in any easy way. So yeah, at least in C++11, that is going to be a headache because you cannot pass the unique footer uh, uh, lambda. Probably you could just call this in lambda and pass it to the unique footer in CVP17, but probably not CVP11, not in any easy way. So you would have to like write this in a function and do some kind of boilerplate code. Yeah. So this is not a good C interface for like for any kind of C++ code. People are going to use your C interfaces in C++, so probably it's better to like take a note of that too. And design your interfaces better for C++ code, because people are using C++ and are going to try to use your code in their code, at least if that's what you're aiming at. So back to the code. We were reading uh, one of these member functions last I remember, which was yesterday. Okay, I guess yeah, we were reading create uniform buffers. I believe we were reading that. Assuming we're not. Okay, let's see if we've already read this one. We have already read this one. Alright, we have read that one. So back to the top. Back to our initialization function to see what's next. This is large, this is huge code. I don't like this code. So if I don't find any interesting code here, oh, there are functions maybe here. If none of these other member functions are going to be interesting, I'm going to like start by refactoring these compute PBR maps. So that's going to be fun, and that is going to help us like understand how to set up a pipeline, a render pipeline, because that compute PBR maps, as we learned yesterday, does make a complete graphics render pipeline and render some stuff. So learning that is going to probably help us learn some of the interfaces, and that will probably make reading the rest of this code easier. So yeah, I'm going to quickly skim through these member functions, which I believe are not going to be that interesting. Like load animation doesn't seem to imply anything interesting there. I think we were reading, yeah, we were reading create resources. And we just noticed that, yeah, what we've noticed so far is that uniform buffers are resources. That was weird. Also, the VBO here, vertex buffer object, is a resource as well, which is kind of weird. I don't know what their design is in here. Capsules. I don't know what these capsules are, but I'm guessing like this is an example. An example. So I believe, yeah, here we are. Let's go on the hair. So I believe they're using capsules on this maybe to cause collisions on here, but I'm not sure. I don't know. I could be wrong, but I believe that is the case. So yeah, so they're adding some capsules. They have some right shoulder capsule. Yeah, they're doing collisions, I believe, but I don't know. GPU presets core. Mm-hmm. Interesting stuff. So they're deciding here whether to use like ultra settings or low settings here. Not a pleasant code, but interesting man. Blah blah, some other stuff here. Add hair mesh. What does this one do? Hair type, blah blah. So we have some static functions here. Yeah. Where is the function? Ah, right. Like destroy hair meshes. set their color, text and stuff, load animations, destroy animations. We will try to make these REI in call mode none, call mode back. What is this? What is this? Create pipeline. That is interesting. Where is this one called? Create pipeline. I think we've reviewed that, haven't we? Yeah, we have reviewed this. I believe we have reviewed this. Yeah, yeah. Okay, yeah. We could start by refactoring this code. This is going to let us give us some insight to the interfaces and how they connect to each other if we refactor these kind of uh, functions. So let's see what we're doing today. We've been wandering around a lot, like 20 minutes in, and we haven't done anything. So let's finish with this. Create resources. From what we understood is that this is a box here, and this is the vertices for it, and it is added as a resource right there. I would like to know how the resource manager works, but this is kind of not that good of a code here. Right, name transform. Name transfer. What is that? G transforms. What does G stand for? Global? Global? Who cares? Well, I guess you would care. This is global. Alright. Name transforms. Hit transform. Name is head. You go here and position. Orientation is no interest. I don't know what they're doing with this name transforms. So these are the hairs. Term selection shading parameter. Color bias. So these are some parameters for simulation of the hair. These probably are being passed to the shaders. I will go with the shaders later. Shaders should be interesting. So some other simulation parameters. And these capsules seem to be being passed to the shaders as well. The shaders are going to do all the simulation on the hairs and stuff. Have hair mesh, hair type, ponytail. This was our member function there. This is an static member function. GLTF, what is that? Alright, just ignoring all that. I really want to like start properly refactoring that stuff on create pipeline. So I'm just going to quickly finish this function here. G vertex count skeleton joints. Multiply by size. This is cost. Joint leads. this null bit here, here, there. Should be this. What is this? So I believe that null footer, yeah, that is the sync token. So these are not asynchronous calls. We could start making them asynchronous calls, but what's the point here? Anyway, let's do that one. Use the standard types as much as possible. This one standard type as well. Remove this. Right. I'm really kind of vague on what these functions are trying to do here. So I I believe we have a starting point here, like on this create pipelines, and I'm gonna try to like start by understanding what this does, which is going to give us some insight on the whole thing. Removing all that. So we have all the code. Maybe add a CPP file. I don't know where I'm adding it, but I'm just adding. I'm going to save this one. I just want to like remove all the irrelevant stuff from my view. Yeah. Okay. I don't know where this is saved on. Probably is it saved? Is it now saved? I don't know. So what I'm going to do is search Skybox and see whatever we're doing with the Skybox and literally remove everything else. We don't care about this one. Don't care. Don't care about any of that. Here, starts on the Skybox, Shadow Pass, who cares? BRD, who cares? No, no, no. No. Alright. That's all we do. Let's see what these interfaces are. Alright. So we're we're adding the pipeline for a Skybox here. So this is what this function does. This could be a simple function called add Skybox, not that, Skybox pipeline. So it tells me what it does. This is adding this Skybox. This is only for Skybox. And what it does is it sets the vertex layout. There's our vertex layout. It's just saying that attribute count. So we have one attribute. Is that it? Yeah. We have one attribute per vertex. That attribute is going to be position, and this is the format of that attribute. So it is a is a four-dimensional vector of floating points, 32-bit floating points, and no binding, no offsets, no locations. Interesting. There's no bindings. If I believe this is, if I don't know. Maybe this is not what I believe it is, but I believe that that is the binding of an attribute to the variable that is declared inside the shader. It's interesting that it's not being bind anywhere. But this is actually telling us about the semantics. Let's see where these semantics are. Oh, so I believe they're supporting up to 9 textures at a time because that is the most they're supporting here. So we're telling the renderer we want such vertex layout for our shader here for our pipeline. So this is the layout of input to our pipeline, and what else are we doing here? Let's try this. So this is just saying that our primitive topology is triangles, a list of triangles. Let's see what other options we have here. So we have almost all the options that are supported by modern graphics APIs. So render target count is 1. So we want to render it onto a single target here. Depth to state, we don't want depth here. It's a footer. Depth to state is a footer. The pointer here. I believe we could make this smaller. And oh yeah, I shouldn't be saving this file. Alright, whatever else do we do here? We're swapping chains here. What? Swap chain? What is this? Render target 0. Format. Ah, so that piece swap chain, I don't know what that is, but probably it has 2 render targets in it, and we're just getting the color format of one of those targets. That swap chain is probably what is being rendered onto our screen. So the render works with like 2 render targets. It draws onto one and then swaps it, and then starts drawing on the next frame on the second one. So it just continuously swaps those render targets and draws on the one that is not being displayed. So we're back. On. Sorry about that. I lost connection. Today is not my lucky day. Yeah. So now we were just figuring out how we're rendering this skybox here. So we have the shader program being set to our shader skybox here. Blah blah blah. So this is the actual point in the code that we have in the skybox. So what I'm going to do is add this function here, the code, move all that irrelevant code here. Let's improve little by little, shall we? So I'm declaring this as a lambda. Pipeline settings. What is pipe? Where is this? Could not find one. Where is this declared then? Oh, it's declared here. So seemingly today I am out of luck. We've just wasted 10 minutes trying to fix my internet. That is not going to be interesting, I believe. So yeah, hopefully everything is going to be alright from now. So what I did was to bring these two variable declaration into my lambda, which is my lambda is going to add this Skybox pipeline. Also, one thing that I'm noticing is this rasterizer state call non-descriptor. Let's see where that was. It's here. Is this being modified anywhere? No. Then why is this not const? Yeah, this is not good code. Let's copy these as well. Let's put it here. And why is this putter? I mean, I don't understand it. Why this is actually a putter. Let me check this structure here. Shader root signature. I don't know what this root signature thing is. What we're looking at is rasterizer state descriptor. I'm going to make this const here and see if the code compiles. Hopefully it does. So I don't think it doesn't compile. Why? I am missing a semicolon here. That is true. My bad there. I hope that's the only error I'm going to get. And yes, this works. So do that. Bring my these two variables up there. Are they? Have I brought them already? I have. So let's see what this actually is. Call mode, depth files. I don't know what these. I do know somewhat what these are. Let's get into details. Okay. And there goes that. We cannot make this cast because of that. This one here. And so this is how we add a pipeline here. So we're asking for no calling here. Here we're telling it what the Skybox vertex layout is going to be. We're assigning the shader here and some root signatures. I don't know what root signatures are, and yeah, some other stuff here. So one thing is I am going to search for global variables in this code. These are global variables. I'm not getting into those. These are probably going to be later on our members. I know for a fact that this is a global variable here. That is the code. I will try to move this one. Okay, let's not do that. Let's first test what we've changed. Okay, so we are here. This is the code we've just written. We have just written the lambda to do all that is necessary to get the Skybox pipeline going. I'm going to remove whatever now is related to Skybox. So I'm removing all this. Like that. And this. So this should still work. Without any Skybox, of course. I'm going to not have any Skybox here. Did it crash? Maybe crashed. So maybe something is looking for a skybox here. So let's call this one from what I believe this code should just work as before, and it does. So yeah, so let's move go on, go further, and also like initialize our excuse me, like initialize and construct our shader here as well. That is going to, like, doing that we're going to avoid this global variable. Not that global variable, but interesting. Pipeline Skybox. Where is this used? Oh yeah, this is an out variable right there. Okay, okay. This is a global variable. We will get to that later on. Let's see where this was. So yeah, I'm moving all this into our new add Skybox pipeline here. So we can see everything in one place. Our create shaders going to ask me to tell him where that pointer to the shader skybox is. I'm going to tell him this way. And of course we're going to have some errors on here, probably on destroy shaders. Going to yeah, another error here. There is this error. Here, let me just correct this here first. So where is our next error? Each one of these could have an error in it. Store root signature. Could be? Nope, it isn't. Prepare. It isn't. Create descriptor sets. Isn't. Create root signatures. So creating root signatures is going to need shader. Why is that? I don't know, but I have no clue like what a root signature is, so I'm just moving stuff here. Sorry about that. We have this missing. At least we can make this local. And our root signature, our destroy root signatures is going to bark at us as to what it is we're doing right now. Now proving that. Removing all this. Now clear that one. And let's fix this error for pure signature. Sorry, my throat is a bit scratchy. This is nothing that we can't move down there. So that is what I'm going to do. So just modify it here. So I'm also going to copy this one, and what did we just copy down here? Was this not related to... Did I copy the wrong thing? Did I? Oh, this is Skybox. And this here. And that's going to set our Skybox, but is this code duplicate as to what we saw above? Okay, there's one instance of this. Then what is this? We have an error here. We seemingly have one more descriptor that is related to Skybox. So I'm going to put this one here to make this one cast the Skybox descriptor update frequency none. Which kind? What is this doing? Like why? Why are there two of these? So I guess there's going to be two of these. If there's two of that, let's not do that. Let's make this cost expert. And let's do this one here. Copy this one from here, go to there, add this one. There goes that. Remove this one first and the 0th. Second. Right. This works seemingly, except that we have a problem here. Okay, this cannot be const expect const. Works fine, doesn't it? Let me ask my Visual Studio just to format this for me. Is there really not a format option here? Like, we're at a point that Visual Studio Code has a better editor than Visual Studio itself. That is sad. So this has to be moved down here. I will try to like make these remove shader, remove root signature, unique putters, but this is not going to be easy since like these two arguments, take two arguments, and that's not going to be easy to do this. Alright, now let's deal with this issue here. But first before that, let's remove this from here. Not there, closest to first use, which I believe is here. Alright, and that's going to bark at us, isn't it? Of course it's going to bark at us. So this is one, I believe this is one case of actual member variable. So I'm gonna make that a member variable if it is needed on different functions here. Like the draw function, like I'm not going to put the draw function there, am I? No. So if it is in the draw, yeah, it is in the draw. So this is going to be a member variable for us, a private one though. This is our member variable right here. This. Oops. Oopsie doo. Let's go to our private section. Only way to create private somewhere close to here. Probably close to there. What is that for? Dry Skybox. What is this called? Draw, yeah. Here are private and here are new. Never variable right here. Sorry about that. So our problem remains these three right here. The enclosing disk cannot be referenced. Yeah. This is going to tell us to capture this, and we are going to do just that. So I'm going to extend this session like I'm going to extend this session for like another extra 10 minutes because I've been disconnected for some time and I wanna be fair and put an hour. Also, I need to like keep an eye on my connection not to get lost again. So that's that. My problems aren't simple. Yeah, I don't know what you call simple. Alright, here we go. So we need these three down there, but what I was thinking is maybe uh, is this actually what we need down there? Let me check. We need them here. Oh, just put there. So p-static sampler names. Why are we assigning it several names? Why? Why is that? Oh, no, no. No, you don't want to do this. This is not fun. And our sample is right there. The interesting thing for me is that we have so many samplers down there. By the way, if you guys don't know what a sampler is, so a sampler has the role of taking samples from textures. So textures consist of few pixels. You could think that you could assume that they are pixels, and yeah. So a sampler is uh, the thing that goes and takes a sample, given a coordinate on the texture. So the texture coordinate system is based on real numbers. Like a coordinate on the texture is going to be defined as two floating points in the range of 0 to 1. So when you tell them like to read some point in the texture that doesn't correspond directly to one pixel, it is going to figure out some way to like get a value for you from the neighboring pixels. So the bilinear sampler is going to like take a bilinear interpolation, do a bilinear interpolation of the value of all the four neighbors you have. Bilinear clamp sampler, I don't know what the clamp is supposed to mean here. and so on. So yeah, the point sampler is probably going to like read the exact point that the closest point that you've been addressing. An interesting thing is that the the Skybox sampler is sampler bilinear. Why would you need that? That is interesting. And of course, this is the number. This is trying to get the count for how many samplers we have there. So this can be cost expert here, and this putter is cost expert as well. Cost as well. Not the putter. The character itself is cost. Alright. The putter is cost expert again, I believe. Putter is cost as well. This is weird syntax. I know, but huh, composite. So from what I know from this, they actually using next to the building, so pasted. Alright, there goes that, and we have an array of const char types. Const char, const prototypes. That is more like it. I don't want to use this. I was just trying to make a point what I mean by this. But I guess the const expert just makes the point enough here in that case. Alright, and here are our samplers. These putters const as well. Samplers themselves are const. Let's see. Let's add some more const here. Const Avon. Const this one. And const the other. Because that is actually how this is treated. Can we ask Visual Studio format for us? Seemingly not. So I've done this seemingly quite recently, and I haven't done this one. So that is fun too. Like this is saying that I have a a const putter to a bunch of const putters to a bunch of characters, const characters. This is not good code. Templates boot help there. Right, anyways. Yeah. That is what I'm going to do there. Going to close that one. Why is this one not compiling? What is it telling me? Must be modifiable. Oh, that you are just modified. Yeah. So I guess it's not up to date. Static, that is const expert, this is const. Remove that spaces here, those spaces here. I'm going to find another solution for this. Like on C++17 you could like use an stud array here, and the stud array would just deduce the number of elements we have in this. Right, and just figuring out after everything is okay. What is this saying? The station must be modifiable air value. Oh. So yeah. I did put an extra const there. This one is not const. Okay, here we go. That's that does have no errors in it. Let's. But hey, there's one problem right now. We moved the assignment of to yeah these where was this these are members, these are our members, and we've like delayed their assignment to this point of the code. So let's see where these are actually used. So from what I believe, this is the raw function. That is our members. This is destroy descriptor sets, which should be alright. I don't know where this is called. Let's see where this is called. Don't tell me this. Okay, that is the exit function. Oh, that's alright. Yeah, this code should work just fine. Let's try that. After compiling, I believe I'm going to end this session. We will try to figure out what we actually achieved after this tomorrow. Alright, we have an error here. Where is the error? Oopsie doo. So we have an insert here. What is it inserting? Samplers. And sampler names. So probably I made the samplers const putters, and this map, whatever this is, wherever this is not const sampler. Yeah, we're just making all the samplers const here. They're not being modified anyways. Alright, see construct. My modifications are going deep into this. And I'm also realizing that I would need to modify all of these errors on Vulkan and D3D11, and that is not nice. That is not good. All right, I'm reverting those changes on about that const sampler thingy. So no const samplers. I don't know why. Maybe they are actually being modified. So get back to our example here. Do not make those samplers const. Where did you make those samplers const? Here. Here they are. No const samplers. Oh, come on. Don't bark at me again. The samplers are not const anymore. Is it? Oh, yeah, we have other modifications. Where were these samplers used? Here, what was this? That. Come here. Those samplers are not const. That's that. This should work. This should work fine. I hope so at least. I know we're doing overtime right now, but yeah, that one is still throws. So that was not the const thingy that caused the problem. I will get to see what is actually causing this problem here tomorrow, I guess. Update descriptor sets. Ooh, update descriptor sets. So this could be a lifetime issue. So that is a lifetime issue. That is a lifetime issue. Yeah, I am going to get this to compile and run properly. So this is a lifetime issue. So as we saw, they're keeping they're keeping a pointer to our samplers out down there in their system. So what we need to do is extend the lifetime of those samplers. So how do we do that? So these samplers are going to be these samplers lives are actually their lifetime doesn't end anytime soon. I don't know what the problem is. Maybe this is the problem. Maybe let's make these static. Same happens. So let's track this one. I'm going to give it one more shot here. What is this code? Where are we? This is the installation. Right. Maybe it's a better idea to get this in debug. So I'm giving it like 3 more minutes and I will try to like figure out what's causing the issue. If I fail, I will fix it tomorrow. Why the hell am I still on release mode? I just changed it into debug mode. We have a link one in here. That is interesting. I will go back to check that volume tomorrow. Alright, where is this one? That is not relevant to us. This is neither. This is though. Prepare descriptor sets. Ooh, so this is lifetime issue. This is indeed a lifetime issue. Let's see what this does. Prepare descriptor sets. Alright, I will get to the bottom of this tomorrow. Yeah, that is enough for today. Like, I've extended this session by 16 minutes already. And we had a linkage error message, warning message here. The object file does not define any previously undefined public symbols, so it will be used by any linker operation that concerns this library. Interesting numerically listed object. Anyways, yeah, that is it for today. Thank you for watching. I will see you next.